What if the ultimate human athletic record, Usain Bolt's 9.58-second 100-meter sprint, wasn't broken by another human, but a machine built in China? At the World Humanoid Robot Games in Beijing, history was officially rewritten. In front of thousands of stunned spectators, a state-of-the-art Chinese humanoid robot named Tiangong Ultra shattered the record books by sprinting 100 meters in 9.39 seconds. Clocking a peak velocity of over 52 kilometers per hour, this mechanical sprinter didn't just beat the fastest human who ever lived, it completely erased the boundary between human physiology and robotic athletic dominance. However, reaching these terrifying speeds came with a violent, chaotic price. Because these machines lack human deceleration physics, crossing the finish line meant charging straight into protective padded barricades at full speed. While Tiangong Ultra narrowly avoided the crowd, its rival, a high-speed android named Lightning, smashed directly into the wall, collapsing into a heap of twisted metal and high-tech components before being carried off the track on a stretcher. What started as a showcase of engineering has quickly evolved into something much bigger, a dramatic turning point where artificial limbs are officially outrunning human biology. If this mind-blowing leap in humanoid robotics gives you chills, smash that like button right now and subscribe to Exoplanet X. We bring you the most intense deep dives into futuristic tech, breakneck AI advancements, and world-changing discoveries every single week. So hit that notification bell and never miss a beat. To understand how Chinese robotics engineers pulled off this historic athletic feat, one must look closely at the rapid evolution of high dynamic actuators and advanced motion control algorithms. Just days before the Beijing event, Chinese robotics pioneer Unitree unveiled an experimental prototype nicknamed Superman. Built in a shocking 3-month development timeline, this android was engineered specifically to push physical movement past biological limits. Utilizing ultra-lightweight carbon fiber leg assemblies powered by custom high-torque joint motors, Superman demonstrated a top running speed of 12.66 meters per second, equivalent to roughly 45.6 kilometers per hour. To prove its explosive power, engineers showcased the robot completing a standing vertical jump of nearly 2 meters into the air, landing cleanly and instantly accelerating into a full sprint without losing balance. These unprecedented physical capabilities are driven by end-to-end reinforcement learning models trained inside ultra-fast virtual physics simulations. Instead of relying on rigid, pre-programmed walking routines, Chinese AI systems simulate millions of running strides across varied terrain within seconds, allowing the neural network to autonomously discover the most efficient gait mechanics for pure speed. This software evolution, combined with massive domestic manufacturing chains producing low-cost, high-density batteries and electric actuators, has allowed Chinese tech firms to iterate hardware faster than any competitor on Earth. As these mechanical sprinters surpass human world records in both horizontal speed and vertical elevation, China is proving that its physical AI revolution isn't just about laboratory demos. It is about creating high-performance machines that redefine kinetic power. Beyond the glitz of athletic stadium lights and viral world records lies a far more unsettling realization. The technology enabling a robot to sprint at 50 kilometers per hour is identical to the systems required for high-speed tactical interception. The same neural networks that adjust stride frequency in milliseconds to beat Usain Bolt are fundamentally solve dynamic stability algorithms. When an 80-kilogram titanium and carbon fiber machine moves at over 14 meters per second, it isn't just an athlete. It becomes a kinetic force with immense physical momentum. In tactical scenarios, urban search and rescue, or military operations, a humanoid capable of sprinting down city streets faster than any human, leaping over 2-meter barricades, and instantly reacting to unexpected obstacles redefines the entire concept of physical security and autonomous defense. This explosive momentum is forcing defense analysts and engineers worldwide to rethink the future of robotics entirely. China isn't just building mechanical sprinters for entertainment, they are stress testing high-stress actuators, power-dense battery packs, and real-time computer vision under maximum physical strain. If a robot can navigate the chaotic friction of a running track while maintaining perfect balance up until impact, it proves that autonomous bipedal systems have officially bypassed the slow, clunky movement paradigms of the past decade. As these high-speed algorithms are integrated into mass-produced humanoid models across domestic and industrial sectors, humanity is witnessing a massive leap where machines no longer adapt to our slow human pace. Instead, we are forced to adapt to theirs. This historic 9.39-second sprint in Beijing marks much more than an athletic triumph. It signals a decisive geopolitical shift in the global robotics race. For years, Western tech giants like Boston Dynamics and Tesla dominated the headlines with balanced demonstrations and controlled backflips. However, China's ability to mass-produce cheap, high-density joint actuators and deploy aggressive reinforcement learning models has effectively flipped the script. By pushing humanoid hardware to the absolute brink of destruction on an athletic track, Chinese engineering firms are demonstrating a relentless, iteration-heavy strategy. While American competitors focus on precision and controlled factory automation, Beijing is building high-speed, hyper-agile physical AI capable of operating at speeds that outpace biological human limits entirely. As we stand on the edge of this new mechanical era, the philosophical implications are as terrifying as they are revolutionary. Human beings spent millions of years of biological evolution, refining the muscular and neurological systems required for Usain Bolt to sprint at 44 kilometers per hour. Yet, a synthetic neural network paired with carbon fiber legs erased that lifelong peak performance in a single 3-month development cycle. As these mechanical sprinters continue to evolve, crossing finish lines and shattering kinetic barriers, we are forced to confront an uncomfortable reality. The gap between human capabilities and machine potential is no longer closing, it has officially inverted. The era of human physical dominance is fading, leaving us to wonder just how fast the future will arrive and whether we will be able to keep up. What do you think about machines leaving human record marks in the dust? Will humanoid robots remain unstoppable athletic marvels, or are we witnessing the early stages of an uncontrollable mechanical race? Drop your thoughts in the comments below. I read and reply to as many as I can. Don't forget to share this video with your friends. Stay curious, and I'll see you in the next deep dive, right here on Exoplanet X.